Hello there guys, how's it going? Mike coming back at you with another video on college algebra. In this video we are going to take a look at graphing and solving single as well as systems of inequalities in two variables. So we could have a single inequality with x's and y's, or we could have two inequalities, each of them in terms of x and y. This is different from what we did much earlier on in the course. We did talk about linear inequalities earlier on, but those only contained one variable. Those only contained x's. Here we have x's and y's. And here also, we're not just solving systems of linear inequalities. We're solving any type of inequality whatsoever. We could have things squared, things cubed, roots, reciprocals of things. So essentially, a lot of things are fair game and a lot of things are on the table. But regardless of whether it's a single inequality in two variables or it's a system of two inequalities in two variables, we're using the same general method for every inequality that is in our given problem. If it's just one, then it's just one. If we have two or more, then we're doing the same general method for every inequality that's in our system. So step one of this general method is to graph the related equations. That is, replace the inequality with an equal sign, and you're going to graph the resulting curve that you get. If the inequality is strict, that is, it's strictly less than or strictly greater than, then when you plot the curve, you have to plot it so that it's dashed. You have to have a dashed curve there. If the inequality is less than or equal to, or it's greater than or equal to, then the curve has to be solid. It has to be a smooth, solid, complete curve. Once you've plotted your curve or each of your curves, you're then going to choose a test point from either side of each curve, not a point that's on the curve, but a point from either side of each curve. Doesn't matter which one you choose. Doesn't matter which side you choose, that is. You're going to substitute that ordered pair into each inequality that is given to you within your problem. If, when you substitute that point in, if it makes the inequality true, then you're going to shade in the portion of the plane that the point is in. If the point, when you substitute it in, does not make the inequality true, you're going to shade in the portion of the xy plane that does not contain the point that you chose. If you had a system of two inequalities, you would do this for one curve. You pick some points that does not lie on the curve, and you shade you shade some part of the plane. You then do the same thing with your next curve. You pick possibly the same point, or you pick some other point that lies on either side of your curve. You plug it in. If it makes it true, then you shade in that portion of the plane where the point was in. If it makes it false, you shade in the portion of the plane where it where the point is not in. So let's look at one sort of basic sample here, and then we're actually going to bring in our graphing calculators into this video, and we're going to see how we can visualize this a whole lot nicer with the use of our graphing calculators. So here I have a very simple, a very basic linear inequality in two variables. 6x plus 2y is strictly less than 12. First thing I have to do, I have to make this less than sign here an equal sign, and I'm going to really isolate one of the variables and then graph the resulting curve, which in this case will be a line. So I'm going to write 6x plus 2y equals 12. And because I'm going to come up with nicer things, I'm going to solve for y. So this means 2y is equal to 12 minus 6x, and that means y is equal to 6 minus 3x. So this is the line I'm going to draw. Now, going back to our process here, we said if the inequality is strict, then when we draw this curve, it has to be dashed. Well, in this case, our inequality is indeed strict because it's a strictly less than. So I'm just going to give a rough sketch of the line 6 minus 3x here on my graph at the right. And I'm going to make this a dashed line. We see that clearly we made some dashes here. That is not a smooth, solid line there. And we had to do a dash line because, again, it was a strict inequality. It was strictly less than. So now the xy plane here is sort of broken up into two pieces, if you will. All the points that lie on this side of our dashed line, and then all the points that lie on this side of our dashed line. So now we come to step 2 in our process, where I'm just going to pick any point whatsoever that doesn't lie on this dashed line, and I'm going to substitute it into the inequality that was given to me. If, when I take my point and plug it in, if it makes this thing true, then I'm going to lightly shade in the portion of the plane that contains that point. If plugging my point in makes this false, then I'm going to shade in the other piece of the xy plane here. And what I recommend is that you always pick a nice point. The most ideal point you can plug in is 0, 0. So as long as your curve doesn't go through the point 0, 0, then you're good. Obviously, this line would never come close to the point 0, 0. So I'm going to test that ordered pair 0, 0. So I have 6 times 0 plus 2 times 0, and I want to know, is this less than 12? Well, 0, last time I checked, is indeed less than 12. I almost got my numbers mixed up there for a second. 0 is indeed less than 12. So this point, which I tested, 0, 0, makes this thing true here. So this point lies on this side of my horizontal line, of my dashed line there. Sorry. So I'm going to draw, horizontal lines, vertical lines, essentially whatever you want to sketch here to show that we're talking about this portion of the xy plane. And you don't have to go all the way out, just some basic lines there just to show that this is what we're looking at. That's fine. Okay, so now let's bring our calculators into this. Let's see how we can use these guys to get at least a nicer visual as to how we can view solutions to inequalities here. So I'm going to go to y equals, where we graph functions. And note that I got this equation down to 6 minus 3x. So I'm going to type in 6 minus 3x. Take a look at my graph here. There's the solid line that's coming down. Now, for the purposes of solving this problem, as we know, this was a strict inequality, so we would need a dashed line. So how can we get a dashed line in our calculators? Well, if you go to the left, as far left as you can, next to this line here, you see this thing that's switching between a diagonal line and then a flat horizontal line at the bottom. If you keep hitting enter, eventually you're going to come to a symbol that looks like 3 dots in a diagonal fashion. If you scroll back over to the right, once you've hit that option, and you now press graph, what we actually have here is now a dashed line. It may kind of be hard to see that it's a clear dashed line, but it's definitely not the solid line as we saw prior to that. So this is how we can just get dashed lines inside of our calculator. Now, what about filling in part of the XY plane as we just did here? I'm going to go back to the y equals, and I'm going to go back over here. Now, as we were scrolling through the options, you saw some choices here where it was, say, it totally filled in that upper right-hand part, and then completely filled in that lower left-hand part. Well, what we're on right now, this option of being totally filled in the upper right-hand piece here, what that's saying is that this is going to fill in the portion of the XY plane that lies higher than your line. Higher, to the right, whatever. The other option is going to fill in what's sort of underneath or to the left of our line here. And this is for this particular sample where we have a line that nicely goes down like this. So we have 2 regions, either lower and to the left or higher and to the right. If you have some other kind of line in here, you may have to play with these options and just sort of see which portion it is that you want. But if I graph this now, it's filling in lines. And there we have our line 6 minus 3x. And we see that our calculator is filling in or shading in the region that we wanted. That same region that we found when we did this by hand. Now, this right here isn't necessarily going to show you that it's a dashed line here, like we know that we should have. That's just something you have to know that, oh, okay, this line is going to be dashed. So that's just sort of the basics of playing with the different types of things we can shade or not shade, or solid lines versus dashed lines. That's sort of how we do that inside of our calculators. So let's do another sample here. Let's do one that is not linear. Here I have y is less than or equal to x minus 2 quantity squared plus 1. This is a relatively nice problem in that when we create the equality, y equals the quantity x minus 2 squared plus 1, everything is already isolated on one side. We have y equal to something strictly in terms of x. And I'm going to FOIL this out. I'm going to do the x minus 2 times the x minus 2 and then add 1 on. This is x squared minus 4x plus 5. There. So this, as you know, is a quadratic equation here. So I'm going to plot this thing in my calculator. Now note that in our problem it was a less than or equal to. So that means that when I plot this thing on my calculator, I want to use a solid line, not a dashed line, because this is not a strict inequality. So I'm going to type in x squared minus 4x plus 5. So there's the graph of this thing here. So let's now pick a point that doesn't lie on this curve. Let's plug it into the inequality that we have here, and let's see if it makes it true or not. Once again, pick the nicest point that you can think of. The nicest point I can think of is 0, 0. So let's test 0, 0. So 0, is this going to be less than or equal to 0 minus 2 squared plus 1? Well, 0 minus 2 is negative 2. Negative 2 squared is 4. Add 1, you get 5. So yes, 0 is less than or equal to a positive 5. So this point here, 0, 0, makes it true. So I want to, on my graphing calculator here, I want to shade in the part of the xy plane that contains 0, 0. So if I go back to my y equals, again, this is now where you may have to sort of mess around with these options here and sort of see what option gives you the portion of the xy plane that you want. Let's just see what happens if I choose the upper right hand piece of this. Let's see. Okay, so that option is filling in everything that lies higher than this curve, but that doesn't contain 0, 0. So this isn't the option we want. We don't want this piece. We want everything else out here. So I'm going to go back to my options, and I'm going to choose that lower piece, everything that's underneath my curve. And there you go. That's the piece that we want. So everything that's shaded here, these are all solutions to this given inequality in two variables. Everything that's in these vertical filling in lines, I put those in air quotes, filling in lines, every point in there is a solution to the given inequality. If you're working with a system of two inequalities in two variables, a solution to the system is a solution that satisfies each inequality individually, but also at the same time. So here is an example of what I'm talking about. 3x minus 2y is less than or equal to a positive 1, and 5x minus y is strictly greater than a negative 1. So here, instead of just having one inequality, I have two of them. I'm going to do essentially what I did in each of my previous two problems. I'm going to do that same thing, but with each of these guys separately. So I'm going to start with the top equation. 3x minus 2y is equal to 1. And again, just to sort of make this nice, because we typically graph things as y equals something in terms of x, I'm going to isolate the y. So 2y is going to equal 3x minus 1. Add the 2y onto both sides, and then subtract the 1 from both sides, and then divide both sides by 2. To give me 3 halves x minus 1 half. Okay, I know that when I graph this line, it's going to have to be a solid line because it's less than or equal to. And again, I'm going to test a nice point, but let's go back to our calculator here for now, just to three divided by 2 times x minus 1 divided by 2, or you could have done 1.5x minus 0.5. Graphing things here, there we go. We see that this line does not go through the point 0, 0. It does get darn close to it, but it doesn't actually go through it. So if I take the point 0, 0, plug it in here, and let's see what I get. 3 times 0 minus 2 times 0. Is this less than or equal to 1? Well, we get 0 minus 0. 0 is less than or equal to 1. So this point makes it true. So I know that I'm going to be shading in everything that lies above this line here. All of this area up here, I am going to shade that in. Now, we're not going to plot it yet, but I know that when it comes time to, I'm going to be using this option right here. I'm going to use that upper shade in symbol. All right, we have our second equation that we have to solve. Here we have 5x plus y is strictly greater than negative 1. Again, replace with the equality. And again, get y by itself. It's just what we typically do. Y is equal to negative 5x minus 1. When we graph this line, we know that it has to be a dashed line because this is a strict inequality. This is strictly greater than. And if I do negative 5x minus 1, let's get a look at our dashed line here. So there was our first line. And this is our dashed line there, negative 5x minus 1. Let's take a point and let's test it. Again, if you look back at our graph here, this one might be a bit harder to see, but if you do indeed zoom in at the origin, you'll see that this dashed line does not go through the point 0, 0. It would not go through it if that line was completely filled in. So we can test 0, 0. So 5 times 0 plus 0 is this strictly greater than -1? And 5 times 0 is 0. 0 plus 0 is 0. 0 is greater than a -1. So yes, this point does make this one true. So I know that looking back at our graph here, since 0, 0 lies above this dashed line, I'm going to need to fill in the portion that lies above this dashed line. So changing my setting for the first one here, and then changing my setting for the second one here to lie higher than that line as well. Now, if I graph these things, this is graphing everything above our first line, and then that's graphing everything above our second line. So, what does the solution to the system of two inequalities in two variables look like here? We said that a solution to a system of linear equalities is an ordered pair that satisfies both inequalities individually yet simultaneously. In terms of this xy plane here and things being shaded in, where are the shadings being overlapped? Because I like making up new words, and shadings is, I think, a new word. So where do the vertical and or horizontal lines overlap? They overlap in this triangular shaped region there. So that area right there, that's where we have all of our solutions to this system of inequalities. So as you can see, it's the exact same thing as what we did from the previous two problems. The only difference is we're doing two of these things in once. Two of these things inside of one problem. So I'm going to challenge you guys on this last one here. Try to come up with a visual on your calculator as to what the solutions of this system of two inequalities in two variables is indeed going to look like. Do the same process that we just did, and then we'll see if you came up with the correct solutions indeed. So press pause now, try to figure this out. Once you think you have the answers, press play, and we'll see if you were correct. Okay, guys, so let's see if you came up with the correct answers. First thing you wanted to do is you wanted to take each of these two equations here, or two inequalities, and solve the corresponding equation. So y minus x equals 2 implies that y is equal to x plus 2, 2x cubed minus y equals 5. You come up with y is equal to 2x cubed minus 5. All right, if I plot each of these guys on my graphing calculator, these are strict inequalities, so we're using dashed lines here. If I look at the graph here, the first line here, as we can see clearly, it's labeled as a dashed here, but for some reason the calculator chose not to pick that up. In terms of visualizing our answers, it's not really going to matter that much. I'm going to change my window just so it's back to minus 10, 10, 1, negative 10, and 10. I'm going to look back at this once again. Again, for some reason, our calculator is not cooperating. It doesn't want to identify the fact that this is a dashed line and not a solid line here. But here are our graphs. x plus 2, 2x cubed minus 5. Let's take some points, test them in each, see if it makes it true or not. So I took the point 0, 0. It doesn't lie on this line. I tested it. It makes the inequality not true. So when it comes to shading in something for this line here, 0, 0 lies underneath this thing. So I want this to shade in the part of this plane that does not contain 0, 0. In other words, I want it to shade in everything above this line. Looking at the cubic here, 2x cubed minus 5. If I take 0, 0, also doesn't make this equal to each other. If I plug it into my inequality, it makes it true. 0 is less than positive 5. 0, 0 lies above this dashed curve. So I want to fill in everything that lies above this funky looking curve here. So I'm going to, again, make the changes. We wanted everything above our line, and then we wanted everything above the cubic function there as well. So if I graph this, there's everything above our line, and there's everything above our cubic function. So what are the solutions? Any point in this checkered area where the horizontal and the vertical lines are overlapping. We know that this should be a dashed line here, as we know that this should be, but for our solutions, we're not going to include the points that lie on this portion of our line. It's everything above this line and to the left of this curve here. So guys, this concludes our video on solving single or systems of inequalities in two variables, as well as how we can visualize these guys on our graphing calculators. This is something where you definitely want to use your calculator to help you get a nice visual as to what the final answer looks like, but there is a considerable amount of the work that you should be able to do by hand. In fact, most of the work you should be able to do by hand so that you know what to plug into your calculator to get that visual for the correct answer. So we're heavily using both things here, both our handwritten knowledge of math as well as our technological part of math, namely our calculators, to come up with the other piece that we need. So guys, if you have any questions or comments, please be sure to reach out to me and ask. Emails, texts, phone calls, voicemails, SOS things, telegrams, secret messages encoded by the German cryptographical systems, whatever you have to do. Otherwise, until the next video, take it easy, guys.